Surgeon General's Family Health History Initiative. And we look at that. This is a free site that you can send somebody to, and they can begin to put their history online, and you can develop their health portrait and their family history here. And you go there, and where do we go? And they can start. Well, that's not it. But anyway, there's one of these links here. Takes you to the place where you can begin putting in information, and then it develops a portrait. Yeah, here we go. And so you can start putting information, and it'll start to develop pedigree for you, and they can maintain it there. And then they can keep adding to it. So you can always keep adding. This is a free thing for people to do to start building those pedigrees, and as they learn things over time, it'll always be maintained there. It's on, it's safe because it's on, it's on their servers, and so you can create this family history, and like I say, people can do this on their own as well as you. I mean, you would. This would be you. This is different at the clinic or the hospital, but you can send people where it gets you started on that. You can start to think about things, and like I say, the more information you have, the better it'll be. And when you first sit down and think about yourself, you sit down and think about it. You come up with half the information when you're trying to think of it. So you get people going on. Part of the thing we're doing here is we're trying to get an idea, what we're trying to develop this idea, what's the risk of them inheriting or transmitting a particular disease. And that's what we just call risk stratification is the term for that. And try to identify that whether or not that you're high risk, low risk, moderate risk for a particular disease, and what are those odds. And we're talking about genetic diseases here, genetic related diseases. This is important because we want to determine, do we need to refer them to somebody else for some more genetic counseling or therapy or particular group, or what do we need to do after that point? Because we're trying to develop this level of risk and see if it needs to be of concern or not. We look for these red flags and see if they need genetic referral. And these are some of the red flags to determine whether or not they need to be referred. And there's this mnemonic here, F genes, like family genes, that helps you to develop red flags. So those family history, is there obvious that the history that there is, you can identify a heritable disease or it's something that's sorted out. And I guess this is kind of general. There's these group generalities too we refer to. We can look for more than one particular anomaly occurring at a time. And if there's more than one, then that's more indicative of there being a particular problem, of it being a genetically related disease. And so oftentimes we'll see, like in the Marfan, we saw one trait, if you see one of those traits, you might think, well, that guy just has long arms. Obviously, the long arms, plus the long fingers, plus the sunken chest, now we put these things together, we have more than one of these, these anomalies occurring. That indicates greater likelihood of being a genetic predisposition for disease. There is extreme or exceptional presentation of common conditions. So things that we might think as not being genetic related, extreme presentation of like cardiovascular disease at a very early age. That's an extreme presentation of a normal type of condition here. If you have recurrent miscarriages, that could have genetic predisposition. Unusually severe reactions to infections or metabolic stress, very unusual reactions to what would normally be just a regular infection to somebody. And then often if you have primary cancers in paired organs, that's multiple primary cancers of different tissues as well, is often indicative of genetic trait there. We have this neurodevelopmental delay, degeneration, mentioned that often mitochondrial problems. If we see developmental delay in the pediatric age group, that's usually, these are high risk as being caused by genetic disorder. And if we see developmental regression in children, or early onset of dementia, sometimes that as well in adults, that sometimes should make you suspicious of genetic cause there. And then the second E is for extreme or exceptional pathology. Again, really unusual tissue histology, if they happen to see something like that, or you get multiple colon polyps, or you have multiple, you get medullary thyroid cancers early on, things of just extreme, really extreme or exceptional. It's very atypical. And then the last thing is you have some kind of really surprising lab value. It just makes no sense at all, and you just have it's just off the charts, and you should investigate why could that be so extreme or so, because there's no reason for that to have happened. So those are just some of the red flags that help to think about it. Abbreviated family history. You want to screen for familial disease. And again, screen some concerns. Do you have any concerns? Ask people if they have any concerns about disease in their family. And so we're going to ask that. Reproduction. Have any complicated pregnancies, infertility, or birth defects. Not just themselves, but anybody else in the family. Early disease and death. Anybody that's died particularly early, and again, any generation they can think of. How would you describe your ethnicity? And then there are risk factors around your family. Ethnicity is because we find there are very certain ethnic groups have very well-defined genetic predispositions for some diseases. So that's an important question to ask that. As correct as we try to be, it's a very important question here. And then risk factors, you just ask, is there any, what kind of, just think of your general risk factors that you talk about in all your classes. What kind of lifestyle do you live? Do you live near a plant that's factory is spewing up toxic fumes and do you breathe that every day? Are you unhealthy? Do you not exercise? Do you smoke? Those kinds of things. Because we'll talk about how they contribute as well. Okay, so we get some ideas, we get some information, and then we start to now we put this together in a pedigree. This is what you have to be able to draw. And so again, it's just a graphic illustration. Multiple generation, have standardized symbols, whether you draw it, or somebody in Texas, or somebody in California, or South Dakota, wherever you draw it, it's going to have the same symbols, so we can relate this information to everybody. And then we have circles for women, squares for men, and the lines together depict relationships, whether they're vertical or horizontal. As simple as that. So, if we look at it again, horizontal connecting lines indicate the vertical lines are lines of descent, and the symbols for all children drawn on the same line. So there's 3 children, 3 offspring families. Okay, if a mother had a child with a man who is now deceased, and 3 children with their current partner, the pedigree is like this. So you don't ignore the fact that somebody's not in the picture anymore. You want to include that in their history. Particularly, if there's a child involved in the picture. So, but you want to make sure it's clear who the partners were for particular children. Here's an example of showing, you can in a pedigree, to show more than one particular trait, you're looking at more than one disease at a time. And you can do that by, you just indicate, diabetes here is a square, this lower left-hand corner, hypertension is in the upper right-hand corner, coronary artery disease is a different color, and asthma is a different color from the square. So you can show, this particular one, they're showing 4 different traits at a time in this particular family. So you can do that. Now, here they're indicating the individual with an arrow. This is the one that was being tested. This is the one that had come into the clinic for the hospital with their problem, and then this is the one that they're trying to treat, and then everybody's developed from that. Okay, so you can get more and more information on it. So sometimes you might not write these things here. You might have a legend, this legend over here, and then from that you just look to see what they have, so you can just think of have this one time and put the squares in wherever. Okay, to be useful, you need at least 3 generations. That's what's it used. At least 3 generations. You use a Roman numeral on the left-hand column, on the left-hand margin to indicate generations. And there's Arabic numerals left to right for each individual generation. So we have the Roman numeral to indicate which generation, and then the number of the individuals across with the greater numbers. Okay. So that's what we keep track of things if you need to write it right somewhere else. We don't want to reproduce the whole pedigree for people that way. Generation 4, individual 3 had this condition. And here's the numbering of pedigree. So we got our Roman numerals and our individual numbers. They can be either above or below individuals. Again, this is the person that's come in to start this history. We refer to that person as the proband. Okay, that's referred to the proband. Usually, you put an arrow to indicate that individual. Sometimes you have pedigree belt. Well, we know those are the only ones that have any shading or any marking, because those are the only ones so far we know have a particular disease. Now, in here, when you include ethnicity, you have to sign and date pedigree. Every time you change it, sign and date it again. The fact that you're the one who made those changes, so they can refer back to you if they need to. Working pencil, you make adjustments and indicate proband. So you always include that information on your documents. It has to be documented, and you have to go follow through that chain of documentation changes that occur along the way. So you always record this stuff. So somebody has to be responsible. Punnett squares, we talked about those, we look at those, how useful they are, and there, we look at see what's the odds of the offspring and developing these chances. And so those are, we can use Punnett square if we happen to know the genotypes of the parents, and for however many traits we want to here. Again, the convention, like we've been using, uppercase letters is dominant, and lowercase letters are recessive a little. And so that's just by convention, that's always the case. And so you can draw these pedigrees out, and these are useful sometimes to show an individual, because sometimes it's hard to say, well, why are the odds that? I had, we had, my grandparents had 12 children, and they didn't follow those kinds of odds. And you can show them. These are very easy to draw. Mother, father, and then she say that. So it shows that 25% chance of having both of those dominant alleles here. And then you can also show, okay, this is a dominant, so these children all have look the same, but nonetheless, they're a carrier now of this recessive allele. That's what matters, that's what you're looking at. And so you have to be sure when you're looking at these here, that the percentages is what you're referring to as genotype, or looking at phenotype here. So here's a recessive trait, and an affected child would be B, lowercase b. The risk that an unaffected child would be a carrier would be 2 out of 3. So maybe there you're just wondering what's the chances of being a carrier as opposed to actually having the disease. So you can answer a number of questions from these very simple diagrams that are easy to generate. It'll fit a lot of things. So be sure you're being careful what you're talking about, genotype or phenotype or carrier status, or what kind of odds you're referring to. When we look at these pedigrees, then all the information has been collected, recorded pedigree, and then we test the pedigree against those possible interpretations. So we do now. We have that pedigree, best as we can get it, and we go back to those criteria that we just went over. What determines whether or not it's autosomal dominant, autosomal recessive, X-linked, Y-linked, or mitochondrial. And then we try to use those criteria and then work through it to eliminate possibilities and then narrow it in, increase the chance of guessing or predicting correctly how it's inherited. So that's what we're trying to do, predict how we're inherited, how it's particularly inherited. And so we go back against those and try to determine. Throw away the hypotheses that don't work, that don't fit our pedigree, and then if only one of them's left, then it's easy. But if you have more than one, you have to try to figure out that what's most likely. Do we know anything else about this particular? Are there any symptoms or what's most likely given whatever else we happen to know about the individual? And then try to make the best guess there. If you're still not sure, you just leave it as, okay, it's either this or this, but I can't say for sure yet. And you work from that. Just do the best you can. When we're analyzing these again, I just want to make a summary slide here. So we know males, females, in diagonal